In this video, we're going to review the kinds of horizontal asymptotes that a power function can have. Okay? Reminder that vertical asymptotes can be found by factoring and setting the denominator equal to 0. Horizontal asymptotes can occur in one of three ways. Okay? So there's three cases, as mentioned the other day. One is if the degree on the bottom of the fraction is bigger. So when that happens, the horizontal asymptote is y equals 0. So in this case, I have x squared on top, I have x to the fifth on bottom. So as the bottom of this fraction gets bigger, faster, this equation is getting closer to 0. So as x gets really big, okay, y gets really small. Okay, that's why that works that way. The other case we had was, what if these exponents were the same? What if the biggest exponents were equal? Okay, when that happened, okay, we use the leading coefficients. So, in this instance, I used one where the equation was 7x to the fourth plus 9x plus 1 over 9x to the fourth plus 2. Well, they both have x to the fourth, so I said my horizontal asymptote was at y equals 7 over 9. Okay, so we've looked at what happens when the bottom is bigger. We've looked at when the top and the bottom are the same, which means the last variation is what happens when the top is bigger. Well, when the top is bigger, you don't have a horizontal asymptote. You have an oblique asymptote. All right, so on that line, I would say none. Okay, and then we have to go on to find the oblique. Now, the oblique takes up a little bit more space because it's also known as a slant asymptote. So finding it is a little bit more of a challenge. Okay, and it comes about when the top degree is larger. In this picture, here's my vertical asymptote, there's my slant asymptote, and my figure stays in between. Now, thankfully, we will not have to graph these by hand, but that's sort of how it looks. Okay, so the oblique asymptote, to find it, you set y equal to the quotient. We actually have to do some division. Okay, so we're going to divide the numerator and the denominator. So I have two examples for us. Okay, here's the first one. I have x to the third plus 5x squared plus 7x plus 1 over x plus 3. Okay, now I'm going to use long division for this. This is something from Math 3, and it's been a little while since we've done this, so I want to break this down as if it were a fresh problem. So I see this. I can set the bottom equal to 0 to find out what my excluded value is, because I need to stay what the domain is. So the domain is all real numbers except x cannot equal -3. And because x cannot equal -3, and there's nothing that's going to cancel here, my vertical asymptote is at x equals -3. That's all the same stuff we've been working on. Now, because the top has a larger exponent than the bottom, the horizontal asymptote is none. Okay, so I'm actually going to write none in there, or NA. Don't leave it blank. So that means I have to find the oblique asymptote. It has to have one. Okay, so here we go. So the top goes inside the box, the bottom goes outside the house. Now, as a reminder, we only care about the front terms. We don't care about the plus 3. I don't care about anything else to start with. I deal with the leading one at a time. So I have to ask myself, what times x will give me x cubed? Well, x squared. And I'm going to write that up here. So now I'm going to distribute x squared to both of these. So I'm going to multiply both of these by x squared. X squared times x is x cubed. X squared times 3 is 3x squared. Now I know it doesn't go all the way across, and it's not supposed to. and that's okay. So now what I'm going to do is, just like all long division when you were younger, I'm going to subtract. Okay, so I'm going to zoom in here a little bit for you. I'm going to subtract. So x cubed minus x cubed cancels. That's what we need to have happen. The very first thing must cancel. 5 minus 3, positive 5 minus positive 3 is positive 2x squared. Now I'm going to bring down the next term. So now I ask myself, what times x will give me 2x squared? Well, that's going to be 2x. So 2x times x is 2x squared. 2x times 3 is 6x. So now I'm going to subtract straight down. 2 minus 2, leading terms cancel, so I know I'm right. 7 minus 6 is 1x. I'm going to bring down the last one, so plus 1. So I ask myself, what times x will give me 1x? Well, that's just 1. So distribute this in. 1 times x is x. 1 times 3 is 3. Going to subtract. I'm just circling those because those are not part of the original equation. So 1 minus 1x minus 1x cancels. 1 minus 3 is negative 2. And if you remember from Math 3, this would be the remainder. Well, thankfully, we don't need to worry about remainders. So I'm not even going to use this. My oblique asymptote is this right up here. That's my oblique asymptote. So it is y equals x squared plus 2x plus 1. And you are welcome to type the original function in to the y equals. Okay, make sure to use parentheses around both of these. And then type this into the y2, and you will see that the end behavior fits this curve. You may need to zoom out. It's not necessarily going to be very easy to see, and that's the trouble with these. It's not often easy to see. Okay, and I want to do one more of these with you because sometimes these are a little, well, they try to pull some tricks on us. So I'm going to go back to my original sheet here. Okay, so I have x cubed plus 2x minus 5 and x squared plus 3x plus 1. Now this would probably be along the lines of one of the more difficult ones we would give you, only because it has x squared on the bottom. But it's still not very difficult. Actually, it's going to take fewer steps than the last problem. All right. So you will notice here that still the top exponent's bigger than the bottom. X cubed, so I'm going to put the top inside the house, the bottom on the outside, and you'll notice that this does not have x squared, but this does. The reason is because I put a placeholder 0 in there. If either of these is missing a term, meaning the powers of x's skip 1, you must put a placeholder 0 in there. If not, your columns will not line up. Okay? And you may not recognize why, but it comes down to, oops, you skipped a placeholder. So, here we go. I ask myself again, only caring about the leading terms, what times x squared will give me x cubed? Well, that's just regular x. Now, some people get really concerned with where do things, line up on the top. I'm not so concerned with it. For some people, it really helps. If they want the x's lined up with the x's, so be it. So x times x squared is x cubed. X times 3x is 3x squared. X times 1 is x. Now, if you notice, I have something in an x squared. If I did not have this placeholder, I would have 2x here, and I could not combine these at all. So I'm going to subtract straight down. X cubed minus x cubed cancels. 0x squared minus 3x squared is negative 3x squared. 2 minus 1 is positive 1x. And then there's nothing left here, so I'm just going to bring down the negative 5. And now, I'm going to take a look here. What times x squared will give me negative 3x squared? Well, that would be negative 3. So now I'm going to multiply each of these by negative 3. I'm going to get negative 3x squared. Negative 3 times positive 3x is negative 9x. Negative 3 times 1 is negative 3. And I'm going to subtract straight down. Negative 3 minus negative 3 cancels. 1 minus negative 9 is positive 10x. Negative 5 minus negative 3 is negative 2. Now, there's nothing left for me to bring down, so this is my remainder. And I know it's the remainder because it has a smaller power than my original answer over here. So with that, this is my oblique asymptote. And this is my remainder, which I don't care about. So the equation of my oblique asymptote is y equals x minus 3. Now, admittedly, this problem here, finding the domain, is going to be very difficult to do because you cannot factor this. So you would need to use quadratic equation. You would not have that on a quiz or a test. Okay? But you would then also be asked about the vertical asymptote, which would be difficult, again, because we don't know the domain. Horizontal asymptote would be none. And we know the oblique asymptote is y equals x minus 3. Okay. So with that, you can type that into your calculator if you like. I believe I already have it in mine here. We go to the y equals. Oh, okay, it appears I have the first equation in there. Oh, no, this is definitely this one. Now if I press graph, I get this graph. It's very difficult to see what's going on. Okay, but here's my line for my x minus 3. The rest of this is the curve for that equation. But if I just press zoom out and then enter, I can see that, hey, the ends are going at that diagonal pace. So I know I'm right here. Now to reset your screen, you're going to want to press zoom and 6. And now you're ready to start your work. Thank you very much, and have a good day.